Hello, welcome back to Calculus 2. Okay, so we will now proceed on Module 4. This is now the applications of your definite integral. So under Unit 1, we will be discussing how to evaluate the area of a plane figure. Okay, plane areas. And in this unit, these are your learning outcomes. First is to understand how definite integral is used in calculating areas bounded by functions. And then, of course, to calculate the area bounded by function using what we call as the horizontal element. And then, calculate the area bounded by the function using the vertical element. Okay, so these are your learning outcomes for this unit. Okay, so application of definite integral in plane area. Okay, so if you try to recall, in differential calculus, the quantity is divided into partial differential parts, while integral calculus is the reversing process that will combine these parts back as a whole. Okay, so how is that? So if you say differential, isn't it differential? You are considering a very small part. Okay, so let's say you are talking about area, then you are considering a very small part. So actually, this is what we call as the elements. Okay, horizontal and vertical elements. So okay, if you try to look at this figure here, these are the functions. Okay, the curves are the functions, and of course it will meet at a certain point, so there will be an enclosed area. Okay, enclosed area, and let's say you want to get the area of that. So considering differential, okay, if you say differential again, you are considering a very small area. Okay, so these are what we call the differential area or the elements. Okay, so I will consider, let's say I want to consider an element or differential area which is horizontal. That means that I am considering a very thin area, or let's say that is just a strip, very thin. And then isn't it that in definite integral from a to b, okay, that is your interval or your limits. From a to b, you are going to sum up all these values, whatever that is in between a and b, and that is the value of your definite integral, isn't it? So we are trying to summate these very small parts. Okay, wherein that is the being divided by differential calculus, and then in integral we are going to sum this all up. So just imagine this differential area which are present all throughout this total area. Okay, so there are a lot of that. Then if we will consider at value the what to call this one, definite integral, it means from this point to that point we are going to summate all of that. Then all these differential areas, if we will summate all of that within this enclosed area, that is the total that we are trying to that we are after. Okay, so in this application we will consider the areas, the quantity, and the element as the differential part. Okay, so again, as I've said, area is the quantity. Okay, and then of course your differential part is the what we call this one is very small here, differential area. Applying the concept of definite integral, we will summate the element leading to the desired area which is bounded by given functions. The intersection points of these functions are the limits of integration. Okay, that is how we will apply your definite integral. Again, considering small part, very small portion, or very small area, or we call that one a differential area or a strip, then summating all of those strip within this bounded area, then that will be the total. Okay, so that is how definite integral is applied in your plane areas. Okay, so now the question there is how we will convert these functions into an equation so that we will apply your definite integral. Okay, so again, since your curves here are the functions, so let's say this is the y is a j of x, this is y is a function of x, it means that they are different functions of x. Then you want to get the area between them from from this point to that point. Okay, so using horizontal element, if you say horizontal element again, this is just a strip horizontally. So again, do you know the length of that? Okay, if you will try to look at the shape, since that is very small, even if actually that is a curved surface, considering a very thin is actually like just like a line, so we can actually approximate that as a rectangle. Okay, making it a curve or straight on this edge will actually be it doesn't matter actually, since again that is very thin. Okay, so that is almost a rectangle. So what is the area of that differential area? Okay, so all you need to do is multiply. What is the length? That is a rectangle, so base times height, isn't it? What is the length of that? Since that is horizontal, so let's say that is x, since we do not know if that strip is this or that or somewhere there, so we do not know, that is variable. Okay, the length is variable, but we know for sure that the thickness of that is very small y, since that is your vertical. Okay, isn't it? Since we plot that one on x and y, it means that horizontal is x, vertical is y. Therefore, that is a very small, since again that is just a strip, so very small. So what is that? That is your differential, isn't it? So that is your dy. Dy, it means very small y. And then what is the area of that? X times dy. Base times height, isn't it? So x times dy. This is the area. This is the area of that differential part. So, isn't it, as I've said, how to summate this one by integral calculus is apply your indefinite with limits. So indefinite integral, integrate with limits. So again, look at this. We are trying to summate. We are trying to summate all these horizontal strips from this point to that point. So we are moving. Okay, so our sign convention here is from below to top. Okay, so that you will not end up with a negative area. So if you have a lower point, that will be your lower limit. Okay, if you are moving up or vertically from down to up. If you are moving horizontally from left to right. Okay, that is how we will follow the sign convention, so that you will end up with a positive area. But again, since if you try to recall your property number 1 of indefinite integral, even if you will interchange the limits, what will just change is just the sign. Okay, so however, as I've said, this is area, so that should always be positive. Okay, so that is using horizontal element. So I will integrate. We are moving up. So what will be our limit? I will be getting the limit. This is a point. So it has an x and y coordinate. This is a point. So that has an x and y coordinate. We are moving vertically. So we should get our limit on y. Isn't it? So y of that is c. Y of that is d. So my limit here is from c to d. Okay. It means that I will summate this differential area, which is x times dy, from uh, from c, okay, from y equals c to y equals d. Okay, or if you did not understand that, all you need to do is get the limit. Since that is dy, it means our function should be in terms of y, so you will get the y coordinate of the point of intersection, and that is your limit. So again, lower limit, since that is the lower point, upper limit, since that is the higher point. Again, I will summate from this point to that point all the horizontal strips. Then if I will summate that, that is now the total area that we are trying to find. However, we cannot integrate this one, since your differential is y and your variable here is x. But we can actually make use of this function itself to change our working equation. This is our working equation to end up with an area in terms of y, since of course we cannot integrate x and dy. So what are we going to do is look at this strip. Okay, the strip is touching the right side of that is touching this y f of x, isn't it? And then the left side of that is touching this y j of x. So it means that if you want to get the value of x, subtract. Okay, since again our sign convention is going to the right or going up. So it means that the x in this point is bigger than the x in here. Okay, if we say x again, that is coming from y. So x on the right side is this. This is your xr. X on the left side is that. So what we need is x. So what are we going to do is x on the right, whatever it touches, minus x on the left. That is the value of our x. So I will substitute that here. Then what will I do? The x, that xr is actually, if I will try to rearrange this y f of x, I will rearrange and bring out x, that is the value of our xr. And then that xl, the same thing. I will now look at the equation of that curve that it touches. I will rearrange that one, bring out x, and then substitute that to your xl. So the xr is in terms of y of this equation, and the xl is in terms of y also of this equation. So now this is in terms of y, all will be a variable of y. Integrate that one, apply the limit. You will have the area bounded by y f of x and y j of x. Okay, so that is our how to evaluate the area using horizontal element. How about your area using vertical? But that will be later. Let's try to apply this one. Okay, this is an example. Okay, so find the area bounded by the curve y equals 4 minus x squared. So again, that's how important your analytic geometry here, because you need to know how to draw your figure. Okay, you need to know what is a curve, what is a line, and so on and so forth. What are the types of curve? So actually, this is just a parabola, or simply just draw that one, and then of course figure out what is being asked. So find the area bounded by the curve. Okay, so this is the curve. I will draw that one. This is the curve. Okay, this is the red one. Y is equal to 4x squared minus x squared, and bounded by that curve and x-axis. So where is the x-axis? This is the x-axis. By the way, I used here my, what we call this one, my grapher. Okay, so if you say grapher, you can install that one in your cell phone, or you can install that one in your laptop, so that you can verify your drawing. Since if you will be having activity, or actually you can make use of the figure of that for your activity. Okay, but if you do not want, if you want to draw it manually, why not? But you can still use that grapher to verify. If you say grapher, all you need to do is input the equation, then that will draw it for you. But of course, if you do not have that, you are expected to know how to draw. All you need to do is assume value of x, solve for y, plot the points, trace, and that's the curve. Or if you know that that is circle, you should know how to draw circle. That's parabola, you should know how to draw parabola. Okay. So again, I've drawn this one. This is our curve, and then x-axis. So what we're trying to find is the area bounded by that. So the x-axis and the curve. So what is the area? This is the area. The shaded part here is the area bounded by this curve and x-axis. So how will I get that? Okay, assume the again, how will I get the total area of that? Is consider a horizontal element or a horizontal strip. However, guys, I can actually draw a horizontal strip from this curve here to the curve there. It's neat. I can draw that strip from this point to that point. However, okay, what is our formula? Okay, look at this formula. I wrote it here. X on the right where the strip is touching minus x on the left. So if you will try to think that I will draw that directly on this part to that side, the x right is this equation, the x left is that equation, it is the same equation. So you will end up this cancelling 0 times dy, that is 0. So you will end up with integrating 0, which you will not end up with an answer. Okay, so what will we do is try to think of this, since that is symmetrical. Actually, I can divide it into 2. Since that is actually there, your y-axis is there, which will serve as our divisor. Okay, I mean it will serve as our partition for this area in this side and area on that side. So let's say this is area 2, area 1, area 2. Again, see, it is symmetrical since that is parabola, and that is the vertex is exactly at the y-axis. So on the left side and the right side is exactly the same. So you can use this side or you can use that side, it doesn't matter. Okay, so let's say I will consider here, draw now the strip here. So my right side is touching the curve. So my x right is the curve and my x left is the y-axis, which is what is x of y-axis. That is actually y-axis is equal to or the same as x equals 0, isn't it? Y-axis is the same as x equals 0. So my x here is the x of that. So all I need to do is rearrange my equation. So I will rearrange that. Transfer x squared on the other side. Y will go minus. Get the square root of both sides so that you will have your x. So that will be our xr. Okay. So again, I will consider area 2, so multiply it by 2 since that is symmetrical, and then I will end up with a total area. X right there is the curve. So x right is the curve, and then xl is, again, as I'm saying, that is the y-axis, so 0. Okay, as you can see, you need to check that one. From this point, isn't it, that is the lowest, so that is where I will be getting my lower limit, and then that is the highest, so that is where I will be getting my higher limit. So I will be summating this three from this to that, and that is the area of the half, and then all I need to do is multiply into 2. So okay, so now let's try to plug in. Okay, but again, what I'm trying to say is that along the way from this point to that point, the x right should be the same all throughout, which is true, and then the x left should be the same also. If later on we will have an example like that. If the x right, x left will change somewhere there, we need to divide the integration into 2. Okay, we will have that another example, but let's focus it here first. So x right is this, x left is 0. So all you need to do is change xr, xl there. So x right, plug in, x left is 0. Simplify this one. This will now be purely equation of y. Okay, so that will be useless. That will be this one, and then of course, why is it that we originally we have there dy. However, for us to use power rule, isn't it? This is power rule. You can consider this as your u, that is your n. You need to have the du. So differentiating your 4 minus y, it should have negative dy. So I will be putting there a negative with your dy, and then balance that 1 by negative here. Okay, so again, do not forget there is 2 there, since again I am just getting the area of 1/2 of that. And then your limit, how did I get my limit? That is the question. How did I get my limit? This is the lowest, so all I need to do is consider a point here, which is actually, it could be the origin or it could be this point. We are moving upward, so I will be getting my limit on the y-axis. I mean on the y coordinate. So y of that is 0, which is the same as that, since of course they are the same elevation. So from 0 to, what is the y of the highest point? That is 4. So I will be integrating from 0 to 4. Now, okay, power formula of this. I already performed there the balancing, completing your du and then balancing that one. That's okay. So we will now follow the n plus 1 over n plus 1, isn't it? So again, we have there 2. Where did that 2 come from? Okay, where did that 2 come from? Later on. Again, this will be, copy that one, n plus 1 is 3 halves, all over 3 halves. So the 3 halves below will flip, so 2 will go on top, so that is 3. Okay, so again, that is just power formula. So that is the answer for indefinite integral. All we need to do is plug in our limit. Okay, so the limit will only affect the variable. So actually, if you want, you can factor out that 2/3 outside. Doesn't matter. That will not be affected by the value of y. But if you want, you can still remain it inside. So plug in your upper limit minus your lower limit. So upper limit, if y is 4, that will be useless, 0. So everything will be 0. Lower limit, substitute 0. So that will be 4. 3 halves times 2/3. Okay, raised to 3 halves. 4 raised to 3 halves times 2/3 will be exactly 16 over 3. Okay. What I did here is I just applied your upper limit, lower limit here below. So still, negative 2 is outside there, not affected. But if you want, so that you will not be multiplying it again and again, you can actually put that inside together. Okay? So it's up to you. This is just now the algebra. So substitute the upper limit, that is 0, lower limit, that is 16 over 3. So minus always, upper minus lower. Then you have there negative 2. So again, this is negative, it will become positive. 2 times 16 is 32 over 3. So that is our area, okay, for the total. Again, I already multiplied it to 2 here, so do not multiply. But if you solve it without that times 2 here, it means that the area, okay, so that is how we ended up with our answer here. So again, if you get the area, if you solve the area without multiplying it by 2, then all you need to do is multiply that one later. But since again, I already multiplied it in our formula, So 2 is already there, so it means that whatever I ended up here is the total area already. Okay, so that is our area bounded by the curve and the x-axis. Okay, so that is for this example. Let's have one more. Okay, let's have one more. So find the area bounded by the curve y equals 3x and y equals x squared. So if I will draw that one, the y, this actually y minus 3x equals 3x is just a line. By merely looking at the exponent that is raised to 1, so this is just a line, this is a curve. So if I will draw, this is a parabola, that is the red one, and then that is the line, which is the blue one, the blue line. So these are the point of intersection. By the way, how do you solve the point of intersection? That is just algebra, guys. Okay, if you are drawing that one, if you are plotting that one, you cannot actually just pinpoint. You are not sure if that is exactly what is you are trying to, what to call this one, what you assume. Okay, you are not sure if that is what you assume is really correct. So what are you going to do is verify, or actually rather get the intersection points by solving these equations using algebra, isn't it? Two equations, two unknowns. I mean, substitute this here, you will end up with two values of x, and then using the two values of x, you will be solving two values of y, isn't it? That is just algebra, guys. Okay, that is just algebra. So again, I will substitute there y here to be 3x. So that is 3x equals x squared. You can now get it means x squared, there are two values of x. You can solve the two values of x and substitute back to this equation or to that equation. You will solve the partner y of this. So you have 2 points. Then you will end up there with 0, 0 and 3, 9. Okay, that is how to get your intersection points. In here, in your first example, there is no problem, since of course, all you need to do is, if you want to get the intersection here, all you need to do is make y 0. Then you will solve for two values of x. Isn't it? If you want to get the intersection of that, actually you can just, that is the vertex of the parabola, or if you want, you can just set. Since this is the y-axis, so that is x equals 0. All we need to do is input that to be 0, therefore y is 4. Okay, so you should know that one. That is just algebra or analytic geometry. Now this is the area bounded here. That is the area bounded. Okay, this is not the area. Okay, others are confused. Look at the bounded. If you say bounded, that is enclosed by the equations that are suggested alone. Okay, so again the same. xr minus xl times dy, integrate that one and apply the limit. So what will I do? My lower limit here is the lowest point, which is 0, 0. So again, we are moving vertical. So I will get it from the y coordinate. So 0 to, that is 0.39. So to 9. Y coordinate of that is 9. From 0 to 9, x right minus x left times dy. This is my strip. All you need to do, if you forgot the formula, all you need to do is try to draw a strip, label that one as a variable and a differential, then multiply that one, and that is your formula. But you need to consider that they are different variables. So you need to consider the right and left, and then change it in terms of one variable only. Okay, so what is the right side of this strip is the curve, the red curve. So that is your y equals x squared. So the x right of that is rearranging, get the square root of both sides. X is equal to y raised to 1/2. Okay, y raised to 1/2. That is your x right. And then x left of that is touching, or the left side is touching the line. So the x left of that is, okay, cross multiply 3 down. So you will end up there, x equals y over 3. Okay, that is minus y over 3. And then of course, play around with this now, x right, x left, play around with that. That's now purely equations of y. Okay, this is purely function of y. So all I need to do is, you can actually simplify it, or if you want, you can actually differentiate, since this is just power rule, power rule. Okay, distribute your integration and your dy, and then power rule, power rule. Okay, so if I will integrate this one, that is power rule again, y raised to 3/2 over 3/2. So 2 will flip on top, so 2y 3/2 over 3. Power rule. Okay, 1/3 is just a number, so y raised to 2 over 2, so 2 will multiply with 3, it will become 6. So negative y squared over 6. So that is our equation. Then your limit is from 0 to 9. Apply your upper limit, you will end up here with 9 over 2. Apply your lower limit, that is exactly 0. So subtracting that, the area now is 9 halves or 4.5 square units. By the way, what is our unit? That should be square units. But if it is given here that your units for drawing that one, okay, let's say that you draw your you need to draw, or the scale of your x and y is millimeter or meter, then you will end up there with square meter or square millimeter. Okay, since again we do not have any specific unit, that is square units, but you need to put there square units for that to be determined as area, because without writing their square units, then that could be any quantity. So we are on area, so even if there is no unit, you need to write their square units. Okay, so that is getting the area using horizontal strip. Okay, one more. Okay, one more is this. Find the area bounded by the curve y. So again, a parabola and another parabola. So again, what will I do? Draw that one. So the red is actually this first equation. The blue is the second equation. These are two parabola. Again, solving the values of intersection is, again, all you need to do is substitute x to be y squared on this side and solve for y. And then there are two values of y. Solve for the two values of x. You will have these 2 points. Okay. So these are our intersection points. Now, all I need to do is draw a horizontal strip. So it's okay, I can draw from this point to that point since the right side and the left side are different equations. So it's okay. Okay, I will draw that directly here. But if you want, you can divide it in half, and then from x equals 1, this is x equals 1 to that curve, and then multiply it to 2. But we do not know. But actually these are two identical parabola, only different opening. Okay, but if you are not sure of that, draw it directly. Okay, so actually I can start from -1 to +1. This is the lowest point. From the y of that is -1, the y of that is +1. So my limit is -1 to +1. Or okay, since this is now identical with respect to x-axis, you can say from 0 to 1. So that is the area here, and then multiply to 2. Or you can consider below from -1 to 0. Then you will have the area here multiplied to 2. So it's up to you. But actually, since it is possible that I can consider from -1 to 1, why not? Okay. So x right, what is the x right of that? Okay, all I need to do is rearrange, interchange. You will have there the x. And then here, x is already there. So x right is the blue. X left is this red. So x right minus x left times dy. And then of course these are the pure equations of y from -1 to 1. Then simplify this one first before integrating. Actually, I can simplify that. That will be -y squared. -y squared is -2y squared. Okay, if you want, you can factor out 2 since actually that is not affecting integration. You can factor it outside, but you can actually do it right away. So integrate this one. So 2 dy is 2y. Integrate that one, power rule, y raised to 3 over 3. So that is 2y 3 over 3. Then you limit -1 to 1. Your upper limit, substitute that. +1 will give you +4 over 3. Minus, substitute your lower limit, which is -1, will give us a -3. So that's why, again, it is important that you should know that will always be upper limit minus lower limit. If you forgot that that is minus, then you are subtracting this, therefore that will be 0. But again, since that is minus and your lower limit is a negative, it will go plus. So you are adding that one. Okay? So, therefore, 4/3 plus 4/3 is now 8 over 3 squared units again. Okay? So again, that is what we need to consider. If you want to consider from this point directly to that point, you need to consider that the right side of that should be touching a single curve, which is true. That is all throughout. If I will consider this, still the blue one is your x right. Consider here, x right is still the blue one. And then same thing on the left side, that's still touching from this lowest point to the highest point the same x left. However, again, let's say there are three curves. So let's say there is a curve, another curve that is passing here. They will intersect at the same point. But the x left on this part below is different from x left on that if there is another curve there. Okay, so you need to be careful with that. If that is the case, then it means you need to get the area here first because your x left is different, and then get the area on top since your x left will be different if there is another curve here. Then all you need to do is summate the total area. Okay. So that is our three example using horizontal strip. So let's have this vertical strip. Okay. This the reason why I am introducing you these two because there are some cases wherein actually you can solve anything, any area, any plane area by sticking to horizontal strip or horizontal element. But there are some cases wherein it will be easier for you to consider vertical strip. Why is it? Actually, the same concept. A while ago, we just considered a strip which is horizontal. That is a differential area. The same thing. It could be a differential area if I will consider a vertical strip. However, the dimension will just change. My length there is already y, since that is changing, we do not know the length of that, since that is different in all of that. And since that is a strip again, the horizontal of that is very, very small of x, since that is the horizontal. So my dimension for the strip is y and dx, so multiplying that one, since again that is considered to be a rectangle, so y times dx, that is our area. And then my limit, where will I get my limit? I am now summating from the left to right, so I am moving horizontally, so I should get my limit from the horizontal or the x-axis coordinate. So from A to B. Or if you again, you should end up with an equation of x that is dx, so I will get the limit from x. Simple as that. A while ago, that is dy, so I will get the limit from y. Okay, so that is the only difference here. So again, I need to make that single variable so that I can integrate. So that y should be in terms of x. So look at this. What is the upper part that is touching this one? So I will be getting the YL. That is your YL. YU. That is the Y upper. And the Y below, which is again since Y is coming from the x-axis. Y below is the Y lower. Then subtract that one, you will get the Y. In any of that is your Y. Y upper minus Y lower always. So again, y dx integral from a to b, and then all I need to do is change the y from y upper minus y lower. Okay, again, our sign convention is that going up is positive, going to the right is positive. So the bigger minus is smaller always, so that we will end up positive. So y upper minus y lower, since lower is smaller. And then if you are considering horizontal strip, y to the right minus y left, since y to the right is always bigger. Okay. Now, that is our formula for vertical strip. So again, there are some problems wherein you can solve, actually you can solve any problem by a horizontal and vertical. Only that, in some cases, the solution in some scenario or in some problem, the solution for horizontal is simpler than vertical. And in other cases, vice versa, the solution on vertical is very simple compared to horizontal. That's why I am introducing you these two, so that you can actually choose. You can decide by looking at the problem which one is easier, x dy or y dx. Okay, so this is vertical strip. Let's try to solve the same problem. This is your example number 1, a while ago using horizontal strip. So if I will summate vertical strip right now, okay, then that will be actually, you can again consider this as a first area and then second area multiplied by 2, or actually, since there is no problem drawing directly from the top to below, since they are different equations, then actually I can consider from this very to the leftmost point to the rightmost point, I can consider it in one integration, so that I will not be multiplying it into 2. But if you want, you can consider from 0 to 2, get the area of this, multiply to 2, or negative 2 to 0, get the area multiplied to 2. It's up to you. Okay. So now this one, y upper, y lower, minus y lower times dx. Integral from your limits. Okay. So I will consider one integration right away. Since again, considering from this point to that point, my y upper is touching a single equation, y lower is touching a single equation. So I can do one integration. Okay. So now, again, my dimension is y dx. So area is y times dx, but your y will be y upper, y lower. Okay, so what is the y upper of that? That is the y of our parabola. So again, as you can see a while ago, that we need the x of that since that is x right, x left. Right now we need only the y, and that is already in terms of y, so that is good thing. Okay, for us, we do not need to be rearranging that one, and the integration later on will be simpler since we do not have fraction, exponent, or radical. Okay, so that is y upper, 4 minus x squared. Then y lower of that is actually your x-axis. It means that is y equals 0. So 0. So y upper minus y lower, this is now purely x. So simplify, that is useless. So we are just integrating 4 minus x squared. So again, that is simple 4x, power rule, x cubed over 3. And then apply, substitute your upper limit is positive 2. Okay, we are moving horizontally to get your limit in x, and that is dx to get the limit of x. So the x of that rightmost side is 2 minus the leftmost side is negative 2. So upper, lower. Okay, again, a while ago the upper is always the top, lower is always the below. In here, the upper is always the rightmost, and then the lower limit is always the leftmost. Since again, we are following the same convention. Up is positive, right is positive. Okay, so now substitute your upper limit. This is positive 16 over 3, and then substitute your lower limit, that is negative 16 over 3, that is minus, so it will end up plus. So 16 plus 16 is 32 over 3. Is that the same as our answer a while ago? Let's go back using the horizontal strip. Yes, and look at this. Which one has a simpler integration? That is the vertical strip. Look at this. This is a radical. Okay, that is a radical. So later on, what if there are x right, x left, which are radical? You will end up with a little bit challenging integration. But still, it is integrated. So that is vertical strip. Let's have one more examples on your vertical strip. So the same thing, we will be solving this example number 2, but this time using a vertical strip. So again, y times dx. Your y is y upper, y lower. Okay, intersection point is 0, 0, 3, 9. We are moving horizontally to get your limit from x. So 0 to 3. What is the y upper? That is the y of the line. Since that is a good thing, since again y is already separated. So y is 3x. And then y lower is the y of the red, which is x squared. So y upper minus y lower, simple equation, simpler than a while ago. So isn't it? Integrate that one, power rule, 3x squared over 2, x cubed over 3. Apply your upper limit, 3 is 9 halves. Apply your lower limit, 0 is 0. So 9 halves is square units. Is that the same as a while ago? Yes, 9 halves. And look at that, there is a fractional. So it's up to you. Again, there are some cases. And I think we will be solving example number 3 using, okay. But you can actually use here, in your number 3 here, you can consider actually your vertical strip. However, just like what I'm saying, if you will consider a vertical strip directly from the top to bottom, that is the same equation, so you cannot do that since that will cancel. So maybe I need to consider using this x as my partition. So I will first get the area on top. Since that is identical here, I will multiply to 2. However, you need to consider also that the vertical strip here is okay, but that should, once it will surpass this point here at x equals 1, the y upper will change to the blue equation. So you need to break this down into 2 integrations. Okay, so you can try that one. So one of your practice, your example number 3 in horizontal strip, you can try that one. Okay, so get the area. You can divide that one into 4. So get the area of this quadrant here, I mean this quarter here, your upper limit, I mean your y upper is y of that, y lower is 0, since that is x-axis. Get the area there, multiply to 2 for the area here. And then plus the integration of y upper here of this equation minus y lower, which is 0. Get the area of that, multiply to 2 for the area of this. Okay, then that is the total area. I'm sure that is 8 over 3 still. Okay, so we can try that. You can try that. Okay, now this is your activity. So let's review some concepts. So both horizontal and vertical elements can be used in any plane area problem, only that one could have a simpler solution in some cases. That is in some cases. Okay, it depends. Look at this example 1 and 2. This we have a simpler integration on vertical. But if you will try to consider example 3 that we solve in horizontal, you need to break this down into a lot. So again, there are some cases wherein horizontal is better, and there are some cases wherein vertical is simpler. So again, you can decide on that. So if the enclosed figure is symmetrical, the total area can be evaluated by multiplying the area of one section by the number of symmetrical parts. So that is what we did for example number 1 on horizontal strip. So thank you very much for watching. If you have a question, you can comment it below the video, or we will be discussing that in the next live meeting. So thank you very much for watching.